Hey there! Welcome to our mini lab. For today's topic, we are going to talk about the Rutherford's atomic model, like this. Before we get to the parts, let's first know the history of the atomic model. John Dalton, 1803. Although Democritus outlined the idea that everything is made of atoms, it was English chemist John Dalton who first began to develop a more scientific concept of the atom. He drew upon the ancient Greeks' idea of describing atoms as small and indivisible. The idea that atoms of a given element are similar to one another, and lastly, different elements have different types of atoms. His model proved these concepts with the notable exceptions of isotopes of different elements. Joseph John Thomson, 1904. Thomson discovered that the atom wasn't as indivisible as previously claimed. He devised an experiment by using cathode rays produced in a discharged tube. He found out that the rays were attracted by positively charged metal plates but repelled by negatively charged ones. He then deduced that the rays must be negatively charged. According to him, the rays were 2,000 times lighter than hydrogen, and he then discovered the atom when he changed the metal plates in the cathode because there were particles that were present in many types of atoms. With the plum pudding model, he envisaged the atom in a positive charge, with the electrons dotted like plums in pudding. The model, however, was disapproved by none other than his students. Ernest Rutherford, 1911. Rutherford devised an experiment to explain the atomic structure by means of firing positively charged alpha particles in a thin sheet of gold foil. Thomson's model showed the positive charge diffused over the entire atom and that it should show little or no deflection. During his experiment, however, even though the alpha particles did pass through the foil with little or no deflection, there were very small number of particles that were deflected at very large angles in which he did not expect to happen. His only explanation stated that it would only be possible if the atoms was mostly empty space with the positive charge concentrated in the center, which would then be known as the nucleus. And finally, Niels Bohr, 1913. Bohr's model aimed to solve the same problems that was in Rutherford's model, which is the reason for what kept the electrons remain in orbit instead of simply spiraling in the nucleus. He realized that classical physics would not be able to properly describe the concept, and so he used quantum theory to try to explain the arrangement of electrons. His model stated the existence of energy levels wherein electrons are found only in those specific energy levels. This means that the electron energy was quantized and therefore it could not occupy the value of energy between fixed levels. Bohr's model proposed stable electron orbits and as well as the emission spectra of some elements. Moving electrons should emit energy and collapse into the nucleus, but his model didn't work well for heavier elements. Unfortunately, Bohr's model didn't solve all of the atomic model problems as it worked for hydrogen atoms. However, he couldn't explain the observations of heavier elements. Phew! The atomic model came from a long history. Now on to the parts. The atomic model that you are seeing is made up of recycled materials and is put together digitally. For the first part, the nucleus is the most central part of the atom. Protons and neutrons are the two types of subatomic particles that make up the nucleus. The nucleus contains nearly all of the atom's mass. The nucleus volume is small in comparison to the atom's entire volume. Hence, the density of matter in the nucleus is extensive. A proton is a subatomic particle having a mass of 1 and an electric charge of 1. The proton is denoted by the letters P or P+. Protons are found in the nucleus of every atom. The atomic number of an element is the number of protons in its atom. Here's how it's made.
The materials I used were paper cups, scissors, paint, and paintbrush. First, cut the body of the paper cup because we only need the cup's base. Second, paint the base red to match the reference picture and let the paint dry. And we are done. Thank you.
The neutron is a particle with mass is equal to 1 and charge is equal to 0 that exists in the atomic nucleus. In the atomic nucleus, as I've mentioned before, neutrons and protons are found together. The isotope of an atom is determined by the amount of neutrons in it. Despite the fact that a neutron has a net neutral electric charge, it contains charged components that cancel each other out in terms of charge. Here's how it's made.
The materials that I use is a used paper, a blue colored paper to color our neutron, and lastly, a marble to help to shape up the paper to sphere. Before I crumple the paper, I firstly put the marble in the middle because this can help to shape up our neutron to sphere. And I add another layer to completely shape up the neutron. And lastly, I now put the blue colored paper to color our sphere. And there you have it, a recycled neutron sphere for Rutherford's atomic model.
An electron is a negatively charged component of an atom that is stable. Electrons reside outside and around the nucleus of the atom. In comparison to a neutron or proton, each electron has a modest mass and carries 1 unit of negative charge. Protons and neutrons have substantially more mass than electrons. Here's how it's made.
For electrons, we need to get straws just enough with our parts. Next is flatten the straw like this, then twist it around and fold it like that. Second to that, get the left part of the straw and hold it and fold it this way and vice versa. After doing that, fold the middle part into a triangle. Then, turn around the straw and repeat the process all over again until you manage to reach the end. You need to put the other part inside the hole so you can have this final product here. And that's all to do a star-like straw to represent the electron.
Electron orbits is the route of an electron around an atom's nucleus orbit. An established course of travel or axis is referred to as an itinerary route or path. In chemistry and physics, an orbital is a mathematical expression, sometimes known as a wave function, that represents features of no more than 2 electrons in the proximity of an atomic nucleus or a system of nuclei, such as a molecule. Here's how it's made.
Before we start the procedure, let me show you the materials that we need to make the orbit. An illustration board, scissor, and glue gun. To start, cut an oblong shape on the board. Also, cut the centerpiece to form an orbit shape, and do the same procedure until you gather up 3 orbits. And now, we finally have the 3 orbits. Then moving on to the last step, I use the glue gun to combine the 3 orbits. And that is all on how to make Rutherford's atomic model orbit.
I think I covered all the parts of the atomic model. Let's have a quick rundown of all the parts, shall we? The atomic model has a nucleus, which the protons and neutrons are found, the electrons, and lastly, the electron orbits. That's all for today's lesson. See you around!